Thank you for joining us today for the webinar, How to Prove You Deliver a Healthier Home with my good friend, Corbett Lunsford. I'm Nikki Kruger, the Building Science and Business Development Manager for Thermostor. We manufacture Santa Fe freestanding dehumidifiers and ultra-aire by Santa Fe whole house ventilating dehumidifiers. As many of you know firsthand that homeowners are seeking indoor air quality solutions for their homes, and they want ones that have proven results. But what does that mean, and how do you deliver it? Today, Corbett is going to discuss the key methods for measuring, fixing, and communicating the health of homes you work on every day. For those of you that do not know Corbett and his wife, Grace, they have created the first TV series about home performance called Home Diagnosis, which airs on public television across the U.S. They have hosted over 500 YouTube videos and 80 interviews for the Building Performance podcast. In addition, the Lunsfords are home performance testing experts who can also train professionals through their Building Performance workshop. Before handing it over to Corbett, I just wanted to let you know that you can ask questions by using the comment box located up in the right-hand corner with the question mark on it. Corbett and I will be answering these questions at the end of the presentation. And with that, Corbett, take it away.
Awesome. Thank you very much, Nikki. Okay, everybody. So if you're not familiar with what we do, I just want to make sure that you have the ability to use your question pane well. Everybody just raise your right hand. Let's all do this. This is fun. I'm going to do this tomorrow with a live training too. Repeat after me. Sometimes I'm an idiot. It's okay. We all have questions. No one knows everything. Anybody who says that they know everything about what they do is either naive or lying. So the thing that we need to talk about today is how to prove that you deliver a healthier home. This is part one of a three-part series. So this one is geared toward professionals, although today and hopefully later also, homeowners will be watching this and learning about what the kinds of contractors that they're looking for can deliver for them and how they operate, what kind of uniform they should be wearing, what kind of equipment they should bring into the house, what kind of products and systems they should be installing in the house, and how they should be proving that they actually work. Part two, which is going to be in 2 weeks, please sign up for that one. It's free also, is about the myriad of problems of HomeChem, why you should care about this. I'm going to be able to gloss over some of it in this hour presentation today, but next time is really a deep dive into that. We actually are dedicating an entire episode of Home Diagnosis Season 2 to the problems of HomeChem, the headaches. And then part three is going to be all about the solutions, a deep dive into like the particular tools, systems, and techniques to address these problems that we're talking about today. So this is kind of just keys for you, the professionals, to understand. This is the baseline. These numbers are the first place that we want to start. These numbers mean that you cannot keep on doing work as usual. Business as usual does not work anymore because of 78, 70, 50. These are the same units, as a hint. If you've seen me talk about this a little bit before, you may know that these are years. 78 years was 79 last time I gave this presentation. Average life expectancy in America. That's men and women averaged. 70 of those 78 years we will spend inside of buildings. And if you add in vehicles, then it goes up a little bit. It's about 90%, let's say. 50 of those 70 years that you spend inside of buildings, 50 years are spent in your own home. When people talk about all the differences between people's health today, obesity, ADHD, allergies, stuff like that, and then we talk about how it's different from before and people come up with vaccines as the answer, for sure vaccines might play a part, but like, look at this. What we are building for people and what we're improving for people has a huge impact, obviously, on how their body will operate. So, first thing to understand, everybody repeat after me, every home is a system. My home is a system. You need to say that to yourself every time you're about to do anything to your home, your family's home, or to one of your clients' homes. Because if you just plug in a box, and that goes for dehumidifiers too. I'm super happy that we're collaborating with Santa Fe on this webinar series because like they really want to get across as well that if you have a problem house and you just take one of their beautiful machines and you just plug it in, it's not going to fix the problem. The home is a system. That's what they really want to make sure that you're able to elegantly tune the whole thing so that a beautiful machine like a dehumidifier or like a ventilation device or any of the things that we're going to talk about today actually works. First thing you need to understand in this system is physics. Most people have some kind of a basic training in this. Building science is what we typically call this, right? It goes way deeper than that, though. We have chemistry also, and almost no one in the building industry and almost no one in the home performance or building science niche within the building industry understands chemistry. And then the third piece is microbiology. So these three things will interact as a system as well, and you need to be able to at least understand that they are at work invisibly in your clients' homes, in the home where you're sitting right now, probably at home. If you're out in the field, it's happening in the vehicle that you're in. It's very interesting. So the second thing to understand is that nobody is regulating this. If you are meeting code for buildings, the energy code is the one that has to do with air tightness and ventilation and things like that. Energy code does not protect against health problems. It's an energy conservation code. EPA is monitoring outdoor air pollution. If they really cared about people's health, they would have been monitoring the indoor pollution all along, because I'm going to get into that. That's way more important for people's health. The FDA monitors things that go in your mouth, not into your lungs. CPSC is monitoring things that are in the products that we buy, materials and stuff like that. And then OSHA is obviously monitoring us while we're at work, but nobody's like helping these homeowners to make sure that they're not doing crazy stuff in their house. That's your job. And the quicker you can become an expert, a higher level professional, and start wearing a new uniform and earning a new pay grade and getting new levels of respect, the better. So in order to think through home performance, there's a really quick way to do it. 4, 3, 2, 1. I talk about this a lot. There's 4 elements to home performance. There's 3 recommendations to make on any home to improve the performance. There are 2 systems at work that you need to be tuned individually and tuned to each other. And there's only one goal for doing all of this stuff. Incidentally, the 2 houses that you see on my screen right now are this way of thinking put into a physical object. The one on the left is my tiny house on wheels. It's called the Tiny Lab. We toured that around 13,000 miles around the country, went to 34 cities, talking about building science and showing people what it feels like and smells like when a house is high performance. The one on the right is the house that I'm talking to you from right now. This is my training center and multi-purpose room. It's also a dance studio. Anyway, both of these are examples of how easy it is to do this, because I already told you, sometimes I'm an idiot. I used to play piano for ballerinas for a living until 13 years ago. If I can do this, any contractor can do this stuff. This is not rocket science. The 4 elements that we need to talk about are, number 1, heat bleed. If you ask anybody in general what they think their house needs in order to become more high performance or energy efficient or healthy or whatever, they might say 3 things generally. I know I found this because I've asked a lot of people. New windows, a new HVAC system, and more insulation. Those are all probably wrong answers in 90% of cases. And I know that because I've tested those same houses that people say those are the things that they think. Those 3 things all have to do with heat bleed. So at least people are thinking about that. That's good. The second thing on the list here, and this is number 3, we're going up in order of importance, is airflow and pressure. Who's supposed to be the expert in airflow and pressure in the trades? It's the HVAC professional. And if you don't know already, if you are an HVAC professional, you know this. Most HVAC pros are not given the training or the tools or techniques to be able to test the home as a system. They might have a manifold set to be able to test the pressures and temperatures inside the refrigerant line, but that's just one piece of the system. So this is a widely misunderstood piece of the puzzle, and it's very important for the rest of the things that we're going to get into right now, which is moisture and air quality. 2 very important things, and 2 things that will tear your house apart and tear your family apart if you let them. And by the way, if you're not aware that environmental sensitivity is a thing, you need to tune in for part 2 of this webinar series, because it is more and more common. I have clients all over the country and overseas who keep coming to me and saying, I think my house is making me sick. And it might not have been the source of what makes them sick, but it's happening, and you need to be aware of that at least. By the way, the thing that I am not talking about today is energy efficiency, because energy efficiency ends halfway through my list, and it only counts for the least important 2 things on the list. If I handle moisture and air quality, if I test them, if I try to improve them, I'm not messing with energy. In fact, what I'm doing is making the house less energy efficient. Plugging something like a dehumidifier in uses energy. That's not energy efficient. If you want to be the most energy efficient, you go live in a cave. If you want to have a healthy family and a wife who has comfortable feet all the time, you have to take this seriously and not always be after energy savings. It's okay. Things cost money. So these things break down into, you can really get granular, and I'm not going to do that right now, but you just need to understand that like each of these elements is, of course, made up of a bunch of different things. And one of the things I'd like to point out is, as far as imbalances go, on the airflow and pressure side, as an example, That's something that can be bad if you have an unintentional imbalance and you want to tune it or balance the home, then you would fix that balance and make it not imbalanced. But in this room, right, that I'm sitting in right now, I have intentionally put imbalances into the system to make the system work the way that I want it to. So you can start messing. If you think creatively about this and you start thinking this way, and by the way, this is literally the way that I think when I'm in my clients' homes, then you will start to be able to think creatively, think outside the box. The 3 recommendations that I'm going to talk about right now are not what is in this picture. That is totally misguided. Number 1 thing that we're talking about is air sealing. If you do not know this already, duct tightness is important. Air sealed enclosures is super important. They are both required by code in most states in the United States of America. Cheap, costs no energy. You do it one time and you never have to do it again. Only after that you do insulation. And again, cheap, costs no energy, only do it one time if you do it right. Third thing that you get to is mechanicals. Problematically, most homeowners are going to call an HVAC professional about any of the problems that we're probably going to tune in on today, which are the health problems, smells, moisture problems. I feel funny when I'm in my house. HVAC guy, clearly, right? That person is going to come in and address number 3 first. It's never going to work because of the 2 systems at work in the house. The first system is the skin. It's called the enclosure. You might hear it called the envelope. It is the air seal and insulation layer. The second system is the engines, anything that moves heat or air around within the house or between the house and outside. That counts for like bath fans and fireplaces, and even refrigerators move heat from one place to another, right? So all those things are interacting with each other. That's the dynamic portion of it. If these 2 systems disagree, the enclosure always wins. You don't have to take my word for it. You can either start testing yourself and find out, or you could just wait and find out that the systems are not going to work because the enclosure isn't tuned properly. So the one goal of doing all this stuff where we analyze based on the 4 elements, heat flow, airflow, pressure, moisture, and air quality, make the 3 recommendations, air sealing, insulation, mechanical upgrades on the 2 systems, the skin and the circulatory system, is not energy efficiency, it's not sustainability. I argue it's not even comfort, because if you sat down with me and my wife and you said, I'm going to make you both more comfortable, you'd be a liar. Because what she thinks is comfortable and what I think is comfortable are 2 totally different settings on the thermostat. So don't tell people you're going to make them more comfortable. Tell them that you're going to give them control over their home. It will do what they want it to do and not what they don't want it to do. All you have to do to have a high performance home is control heat bleed, control airflow and pressure, control moisture, and control air quality. So your question now is, well, how do I know if I am giving my clients that control? There is only one answer for this. It is this stuff, testing. If you are not testing, you are not doing home performance. You could be installing ultra-aire, highest performance systems in the world all day long. You could be installing ERV ventilation in every home. And if you're not testing it, I guarantee you they will be calling me next to solve the problem. Please take this stuff seriously. This is not hard to do. There's tons of free, the 500 YouTube videos that Nikki mentioned at the top, those are all available for you to see, to just like learn how to do this stuff. It's just super important. So here's the ways that we use these. Number 1 is if you want to solve a complex problem and you know that you solved it, you don't like lie awake at night thinking, is that really going to work? I'm not sure. I was just guessing, which is 99% of what we do in construction, right? Second thing is that you want to help somebody prioritize home improvements. They're going to pull a permit. They're going to do an addition or a renovation or a remodel at least. And you want to just make sure that they're taking advantage of all the opportunities for improvement and prioritizing them correctly. That's what you do. And lastly, you provide proof and peace of mind, not only to your client, which is invaluable. Most people do not trust contractors. We know this. If you don't know this, you should go ask more people. You need to be the kind of contractor. Don't fight against that. Like, just let that be, but be the kind of contractor that is the anti-contractor that's going to actually do what nobody else is doing and provide you with that proof that you got what you paid for. And you need it for yourself, because this is a very litigious society. If you really want to go out there and put your liability down and not know what you're doing in homes, and I guarantee you that most contractors do not know this, because in my first year, after I was a piano player for ballerinas the year before, I'd go out and I would tell people that the contractor they just had in didn't understand the home as a system. They will not call that guy back. So don't be that person. There's all kinds of weird stuff that we're seeing in homes that may look okay. Somebody just called me yesterday about, like, I've got spray foam that's going into this house and I'm blower door testing it as they're testing it, and it's as they're installing it, and it's not doing well. They sent me a picture. It looks terrible. Like, people need to know the difference, and they're starting to know the difference. You need to protect your own reputation with testing. First thing is that everything that you do in a home will have side effects, period. If you take out, you turn a furnace from a normal efficiency to a higher efficiency. You do something to the house. You remove a fireplace. Good for you, but you did something to the house. What did you do? You replace the windows, you add insulation. You can create mold in a home by doing something that's good that people are going to get a tax credit for, and that you might get an energy company rebate for. Please be aware of this stuff. Second thing is that people, normal people, will live in their house for a year after you did something great to their home and you tested all the side effects and you know what the house is supposed to be doing. And they'll call you back and say, you know what, the house actually slipped back and now it's uncomfortable again. If you have the data of what it actually was doing when they said, wow, this is great, and you could test it again, you could say, actually, the house hasn't changed, you've changed. Your perception of what the temperature comfort zone is has gotten a lot narrower. You're a lot pickier now. And so it's the same house. It's actually literally performing the same way, but your perception has changed. If you have data, you will win every argument. And I speak from experience. Third thing is that people, your clients, will be testing their own homes. And one of the ways that they're learning to do this is from me. I will be teaching them this on Home Diagnosis, on public television for free, and on our YouTube channel for free. So this is good. An educated customer is your best customer, period. Don't let anybody tell you that, like, oh, my client spent some time on Google and now they know everything. They just want some information and they weren't getting it from us. So they had to go somewhere that's maybe not very legit, like a forum or something like that. These tools that you see in the bottom right are not good. These are not good tools. You can afford better tools. So if you have a better tool than they do, and by the way, this is one of the reasons that somebody's like, oh, should I spend $500 on an infrared camera? And I'm like, okay, that's fine, you can do that. But if somebody comes along with a $2,000 camera, they win, period. So just understand that there's testing going on. You need to be, if you're going to be a professional, then have a higher level of data, have a higher level of tools. Nikki, do you have a question popping up? Okay. Testing invisible stuff. Here's what we're using. Blower door, pressure gauge. If you're not familiar with this list of stuff, then you please do tune in to both what ultra-aire and Santa Fe are trying to get people to do to confirm and verify that these, the systems are working, and to understand the whole home as a system before you start spending your clients' money on stuff. All of these things are widely available. All of these things are getting cheaper all the time. And I use them in every one of my clients' homes. I take about $15,000 of testing equipment into my clients' homes when I go and visit. Here's an example of why you should definitely be paying attention to this. I built both of these homes that you see in the pictures, right? This is my tiny house on wheels and my big house. I have never built a house before. I had to learn how to use the nail gun to build that tiny house. I got that house to get these 3 blower door readings. And you don't have to understand blower door technicalities. I'm just going to tell you what these 3 pictures mean. You can see that the top number where it says at is on, next to that is 50.3, then 51.0, 48.8. Those 3 numbers are essentially the same. We call that about 50. That's the pressure that we build up in a house when we do a blower door test. Everybody say blower door test. Got to call it by the right name, especially professionals, right? I teach the homeowners to do this too with you guys so that we're all on the same page about what it is that we're expecting. The first picture here, 47.1, is my CFM reading with the blower door running. That means that if I was to have installed a bath fan in the bathroom of this house, because I'm a normal builder and I do what's expected of me by code, which is I put in spot exhaust, the bath fan that I would put in from the big box store would be 50 CFM. Therefore, every time I turned on that bath fan, I would be running a blower door test on this house. That is the worst thing I could possibly do to this house. I would grow mold in the house within about 2 months, and I would lose my shirt. You can't do that anymore. Middle number, 1.39, first-time home builder. I beat the code minimum air tightness that will ever be enforced for any builder in the entire United States of America, which is 3. I beat that by double my first time out. And by the way, doing that on a very small house is hard. The third number there is passive house air tightness level. I'm on a webinar right now. Please leave. So in order to understand how this works, I just want to tell you that an idiot who has never built a house before, achieved an insanely airtight house. If you build houses, or if you know builders who are building houses, I apologize for my little girls, by the way. This is, pandemic times. You are accidentally building airtight. All of us are. I've tested tons of houses where it's the first time that the builder's ever been tested, and they came in at 2 air changes per hour, more than double what the state of Georgia is right now, which is 5. And they haven't been installing ventilation systems at all, or dehumidification systems at all for years. And they've probably been doing that. They're going to have major callbacks, and it just is a matter of time. It's less and less time at this point. Picture on the right is my new house, 300 CFM. This house is, you can see I've got 2,000 cubic feet in one house, almost 50,000. This house is 25 times bigger than the tiny house, and I got a number that's 6 times higher with my blower door. Now I know what I'm doing, and I could actually really rock it. And you're doing the same thing, whether you like it or not. We're using plastics, we're using AeroSeal, we're using all kinds of different things that are affecting how things are working. So tools for tuning homes. Number 1, heat bleed, right? This is the first element. You're talking about air sealing and insulation. Easy to do. Any of your competition could pick this up tomorrow and start testing themselves with blower door, and they will beat you on every single job because they are proving that they're giving people what they're asking for. Airflow and pressure. We need HVAC design. How many people actually do this? If you're an HVAC professional, you know, not very many. To do an actual room by room manual J calculation with an actual manual D calculation, and use actual manual S to select the equipment, which is, by the way, again, required by code in most states. And then to supply makeup air for a house that you know how airtight it was, because when you turn on the exhaust hood over the kitchen, it's 500 CFM, you got a 500 CFM blower door. I am doing a blower door test every time I turn on that kitchen exhaust hood. Things like that start making a difference. Moisture, you need a dehumidifier. Almost everybody in building science world is agreeing that we just need to have dehumidification built in to every home. Now that we're building so airtight, there's just nothing to do about it. Also, weather is changing. I don't know if you guys are aware, but there's something called design day drift that has started to happen, where the actual weather patterns are shifting, and we're trying to change the design days that we use in those HVAC design calculations. Number 1, air quality. You got to have spot ventilation. Got to have whole home ventilation. You can use a variety of different things. We're going to talk about that in the 3rd webinar, but you just have to just start somewhere with all these things, because this is where everything is going. If you are not doing these things, then there's something that's going to happen to you soon. To give you an idea of how crazy you can get, we did what we call a hurricane test on this house. And this is to make sure that I know where all the moisture leaks are. We ran the blower door to 250 pascals. That's 5 blower door tests at the same time with 1 blower door. And then I had my friend Landis Bennett, who's on my channel on several videos. He's awesome. Run a pressure washer and spray my house down. So we were simulating wind-driven rain. I am putting this on public television so that normal people can see how you really build a house if you want to make sure that you know that it's going to work right and it's going to last a long time. If there's any builders in the world who have done this, please reach out to me so that I can give you a plug on my channel. I'm positive that there's actually nobody who's probably done this before, so it's not hard to do. It took an afternoon. But of course, when moisture does get into your house, because that's one of the principles, is like, make sure that it doesn't happen, but when it does inevitably happen, because this is life, you want to make sure that your materials can dry. We all get really hung up on like where the vapor barrier should be or what the perm rating and all. Like, don't worry too much about that. You look at these schematics here where it's got the layers and you're like looking at all where the air sealing layer. Just make sure that everything can dry in general is my advice. And I've gotten that advice from scientists and researchers, by the way, like Landis. Just, you need to make sure that the house can breathe. So plastic, generally not a great idea. Bathroom floors, showers, bath enclosures, crawl space floor under the slab, great idea. And you also need to have machines available to handle that, because we are going to have spikes. Your daughter is 5 years old and she is going to leave the window open all night long, and you're going to pick up a bunch of humidity. You want to make sure that doesn't go into the couches and then come out for the next 2 weeks. This is what it looks like when you start to test these things. This is the weather. This is 5 days. You can see the temperature go up. It's the blue. And then it goes down at night. It comes up in the daytime, goes down at night. That's 5 peaks and valleys. You can see the relative humidity, which is the orange line, go down and up. It's inverse of the temperature. once you start testing these things, you'll see that happen. And you'll be like, oh yeah, that is what happens when it's uncontrolled. And there's kind of a typical, just nothing is really happening on the moisture. When the temperature goes up, relative humidity goes down, because relative means it's relative of the temperature. And then the gray line in there is the dew point. And that's really what we need to get at. And that's something that you don't want to talk to your clients about. Don't say dew point to your clients. We should be talking about condensation problems and moisture damage and things that are actually like graspable by most people. If we get too technical, we're going to lose them in the weeds. Here's what it looks like when you start to actually try to control it. You can see that everything now lines up. This is humidity control only in a small space. This room is 250 square feet. It's where I keep my tools. I call it the dry vault. It's a tiny, airtight, insulated, and dehumidified, but not conditioned room. I don't care what temperature it is in there as long as it's dry. So that's a dehumidifier kicking on and kicking off. And you can see that the relative humidity and the temperatures start to line up. Everything is like playing nice together. This is what it looks like when you have a big space. You don't see the the on, off all the time. So this is a much bigger space. Bigger houses, a lot safer. That's why I'm not a big tiny house proponent. I do have one and I lived in one for 5 years. Not a good idea in general. Very hard to get it right. You got to tune it to within an inch of its life. Big house, which is this one right here, just humidity control, no temperature control, but insulated and airtight. You can see how, wow, that's like pretty comfortable going between 74 and 81 most of the time. No conditioning again. Amazing. That's June, by the way. It's like June 5th through 12th. And this is what real life looks like when you have multiple pieces of equipment, heating and cooling, plus a dehumidifier, and you've got people coming and going and opening windows and things like that. You want to be able to look out for things like this spike, and you want to know when exactly that happened and what that was. Because if it happens on a regular basis, you're like, what happens at 2 o'clock every day? And they're like, oh, the chef comes in and cooks for my family for 5 hours with the exhaust fan on high, which has actually happened. That was a client of mine and Lou Harriman's. This kind of thing happens. So you want to be able to track it and know what's going on when you're not there, because you're only there for an hour, 3 hours, 5 hours. Now, to understand the chemistry side of things, now that we've gotten through the physics, you need to understand that number one, chemicals are a big deal. Chemicals are everything. Anybody who says chemical free that's not a thing. Everything is made of chemicals. I am chemicals. The air we're breathing is chemicals. Some of them are good for you. Some of them are bad for you. Therefore, all you have to do is just control what chemicals are brought in, and this is really, really what's important. You can control what chemicals are brought in, but you need to understand, if you bring things that are reactive into your clients' homes, even if they themselves are not bad for the client is going to clean and cook and be in the space and use Axe body spray if they're 13 years old. And those chemicals are going to meet the chemicals that you brought into your clients' homes, and they're going to meet up with the ozone that's coming in through the window from the street outside. And they are going to have babies. And you will be manufacturing new chemicals that were not there to begin with. Second thing is particles. Particles are bad, period. There's no such thing as like, oh, we want to manage them. No, get them out all the time. They are being created because we are being in our home. Right now, you are sloughing off a cloud of skin cells. It's gross, I know, but stick with me for a second. We're going to lose about 1 pound of skin cells a year, according to the scientists that I have worked with, which is like over the course of a lifetime, like half a person. Kind of gross. Just being here, I'm creating particles. I do not want those particles to go into my lungs because my lungs are like babies. And I don't want to give them things that they can't handle. So therefore, I want to control how many particles are being created. If I have an exercise room in my house, jacked up the pig pen effect. If I cook a lot, if I cook intensely, if I cook Asian style, if I cook Indian style, I need to understand that like those styles are going to impact the chemistry differently. And I want to make sure that they go someplace. And that's what spot exhaust is about. Third thing is microbes. They're here. We all know about the microbiome of our gut by now. If you don't know this, probiotics are good for you. Eat more yogurt. Some microbes are bad for us and some are good for us. They're not all bad. This is an okay thing. In fact, on the walls that you see behind me, there are literally probably millions of animals at work. They're doing their thing. They're eating, they're excreting, they're working. So you don't want to just kill stuff. And this is what sanitizing and disinfecting and everything that we're crazy about in this pandemic is about, because full circle, when you use antimicrobials, you are using chemicals and you are adding chemicals to your chemistry experiment. You have no idea what that's going to do. So we need to use moderation. So here's how you control this as professionals. 3 rules. Number 1, Do not bring bad stuff into people's homes. Know what's in the products that you're installing. Also know what people are going to do. And therefore you want to ventilate, because people are going to do gross stuff in homes. They're going to use the bathroom. They're going to take showers. They're going to cook, and they're going to sleep in beds and like maybe use an exercise room. You got to have ventilation. And the third thing is keep it dry. If you do those three things, you're reasonably certain to have a pretty good air quality. And by the way, number one is impossible. That's why number 2 and 3 exist. If it was possible to do number 1, there would just be one thing. Just don't bring bad stuff home. That's not possible. So here's what you need to understand. They're coming from all over the place. You can see this list. This is called the 6 classes. 1, 2, 3, 4, 5, 6. Fluorinated products, stain-resistant carpeting, stain-resistant furniture. Avoid it at all costs. It's called highly fluorinated. They are forever chemicals. There's no known way to destroy them, essentially. The second thing is antimicrobials. Also not good. I saw recently an ad for a rug. I'm like trying to fill the space up with some sound dampening things so that when I am making music in here, it's not super boomy. And this rug was like both antimicrobial and stain resistant, which is a chemical cocktail. And then the third thing they said was safe for kids and pets. Absolutely not. Your children are going to spend most of their time on the floor, breathing in what's at the floor. And so if you have carpet, even if it's not stain resistant, it grabs a bunch of dust. And then when you crawl over that or breathe as you walk by, kicking up a bunch of stuff into the air. And when it's sitting on the ground, it's safe. But as soon as we kick it up into the air, we start breathing it in. Now it's inside of our bodies and it's doing all kinds of things, upper respiratory, lower respiratory, even getting into your blood. So these things are in the materials that we're putting into homes. They are on the surfaces and they are in the air. It's all three things. And by the way, this is one of the things about something like flame retardants. It comes out of the furniture. If I'm sitting on a comfortable chair right now, it's probably got foam in it, and that foam probably has flame retardants in it. And those flame retardants, which is number 3, is stuff that they took out of kids' jammies in the 80s because it was causing cancer and literal genetic mutation in children. And we put it into furniture instead. It comes out all the time because it's supposed to stay in there for a long time. And it's just that something that's high goes to something that's low. High concentration moves to low concentration. It's constantly coming out. Ventilation, therefore, right? More humidity we have in homes, the more emanation of those particles and chemicals and microbes into the air, because the humidity activates some of this stuff. So you want to kind of think about, one way to think about it is like a room where there are people standing up and sitting down, and it's happening all the time. Things are depositing on surfaces and they're taking off from surfaces. So there's like ways to maybe think about using the humidity to play with that, to create an imbalance intentionally so that you can ventilate then and get rid of some of the stuff that was on surfaces. It's an interesting thing to think about. Anyway, more humidity, also more microbes. You can grow plants in the desert if you have sun and water. In fact, apparently some of the biggest farms in the world are in Saudi Arabia. It's called hydroponics. That's a thing. I can grow mildew and mold on my antimicrobial plastic of my HVAC equipment, because if I just have enough humidity and I have the right circumstances and I don't clean enough, then I get this effect, which is that it is more polluted indoors than outdoors. And this is something that blew the minds of the people on the HomeChem experiment that we were lucky to be a part of. So spot ventilation is the first thing that you gotta have. Every single house, period, in every part of the world, no matter where. We're talking about a TP, spot ventilation, hole in the top. If you don't have the hole in the top, your family's gonna suffocate and die. So spot ventilation here, you can see these are 3 places in my house. On the left, you see a shower. The exhaust port for the shower is in the shower. Don't put it in the middle of the room. It's not going to grab the humidity. Air leaves, right? And then it needs to be drawn in, and it gets drawn in under the door, and it goes and it grabs all the humidity around the shower on its way outside. If you make the humidity come out of the shower to hit the exhaust fan, it's just not working the right way. I can tell you that there's no condensation in that shower so far, and we've been using it for a couple months. My daughter here is pointing to our beautiful toilet. I have put the exhausts for our toilets next to the toilets so that when you're sitting on the toilet, no matter what's happening under you, you can't smell it. Isn't that a beautiful thing? It's not rocket science. It's just thinking about where you want the imbalances to be created and where the airflow and the pressure is happening. So we've got the air leaving through the toilet port there, coming in under the door, and it's a nice thing to have happening instead of having it be on top of you so that any smells that you're generating in the bathroom are wafting up around your body until they go out through the ceiling. It's not wrong to put it in the ceiling, I'm just saying. Spot dehumidifiers. This is another thing that you can now use because dehumidifiers are getting more efficient. And for sure, the imbalances that you're going to see in homes that are bigger are going to be kind of mediated and mitigated by the fact that you've got a big space that's going to diffuse a lot more. But if you can handle the moisture where it's generated, like if you've got a crawl space, get it in the crawl space. If you've got a place like this where I've got this big room behind me, I have one door to outside, that's where all of my humidity is going to come from. And that is also where I've put the conditioning unit, the mini split, and the supplies for my ventilation system. That's where everything is going to get kind of controlled and then pushed to this side of the room. So again, this is just an easy way to try and address some of these things. Now, ductwork. I mentioned that I have a ductless mini split. I also have a ducted system in this house. And I just want to make sure that people are using reason when we start talking about ductless systems, because I get a lot of clients who are like, do I need to have all ductless everywhere? I just want to tell you that ducts are awesome if they're done right. And that's mainly the problem, is that we just don't, not everybody has the time and gets paid enough and has the time to breathe to do it right. This is what it looks like when it's done right. I installed those ducts myself. I'm an idiot. It took me a long time, okay, but they're sealed and they work perfectly. There you can see on the left my heat pump, which is ducted, and my dehumidifier. And those are two very important pieces of equipment in my crawl space. I've got lots of room in my crawl space. Love crawl spaces as long as they're conditioned. So ductless has humidity problems. It's what's called the sensible latent split. And essentially what that means is that the ductless unit that's on the wall behind me, and I'll just point it to you right there, has, they all kind of have this issue, and this is something the manufacturers understand, which is why dehumidifiers are become so important, even in new high performance homes like this, where we got like, oh, it's brand new equipment. 95% of the energy going into that thing is going into cooling the air. Only 5% is going into drying it. So if you have ductless systems, 100% you need a ducted dehumidification system in the house. So you're gonna have to build ducts anyway. So just use, you know, a rational approach as you're doing this. When you are installing ducts, though, you want to make sure that you're paying attention to these things, because you have condensation that can happen if you're going to have ductwork running through interior walls or through an attic. You want to make sure that that stuff is insulated, because if you get condensation on the outside of it when you're air conditioning mode and it drips, it'll spot the drywall. You'll get a call back. It's spotted drywall. Like, it's not that big a deal, but instead of painting it a million times, let's just do it the right way the first time. Edible materials, ductboard. Honestly, anything is edible to the right kind of fungus. And I have an interview coming out soon on the channel with a very interesting microbiologist, ecologist, author, who talks about the fact that there are microbes in the space station. They eat plastic and metal. So nothing is non-edible. I'm just saying that when dust gets on something, it becomes edible all of a sudden. Floppy flex duct is your third problem. Just if you're going to use flex duct, great. There's lots of people in the home performance space who are using flex duct and using it well, but using it well takes some attention. So the dry air, one thing that I want to make sure that is especially clear, because it's because of something that you'll see that's happening in Florida right now, needs to be ducted into the supply plenum, not the return. And because this is a webinar for pros specifically, I'm gonna get a little technical for a second here. The reason that you wanna go the dry air into the supply and not into the return is several-fold. Number one is your air conditioning system, especially if it's ducted, can still dehumidify. 25%, it's roughly a 70-30 or a 75-25 split. 25% of the energy going into your heat pump or air conditioner is going into drying the air. Let's let that happen, because really what we want the dehumidifier, the dedicated dehumidifier, to be is to kind of handle emergencies and be supplemental. You don't want to lean on any one equipment for handling everything, which is why there were several people who, when I was building this house, were like, ooh, you should use my system. It does everything. And I'm like, I really don't like that, because then if it breaks down, I am completely screwed. I think that a system approach is still the way that works from my opinion. But when you do this, how exactly you do it is always the thing. So when you hook it in on the supply after the air conditioner is also dried out air, then you're letting that AC coil get wet, which seals the trap in your air conditioning line, which is also a good thing. If you've got it running outside, you don't have air infiltration. That's like getting a little bit overly nerdy, but I'm just saying. Second thing is that you don't have the re-evaporation. If my dehumidifier kicks on after my air conditioner is kicked off and that air conditioning coil is wet, then I potentially am drying off that stuff because I'm introducing dry air that's going to pick up whatever's on the coil and distribute it throughout the house. That's just not going to dehumidify very well. And Santa Fe is finding, for one, and I'm sure that if we asked other manufacturers, they'd probably say, if they are researching it, they're finding the same thing. It's just not doing as much as it should. So pipe it into the supply side. The condensation protection is the other thing. You can see my supply ductwork there. If you are an HVAC professional, you might have noticed that none of it is actually insulated. And I've been waiting to see if I have condensation problems to insulate that. And I honestly haven't seen any. The air that's coming out from that dehumidifier is going to slightly warm the conditioned air. And so I end up with, it's a more tuned, more balanced, more kind of, the delta T is a little bit lower when it comes into the room. It still cools the house beautifully and everything still works, but it's going to enable me, I think, to not have to insulate the ductwork. I'm not saying that everybody should start doing that. I'm just saying, like, this is an interesting side effect that I'm seeing. Lastly, this is now legally required in Florida. You cannot, apparently, plug in the supply of a dehumidifier into the return. You have to do it this way instead. So just take note, all the HVAC pros on this call. Now, as far as the dehumidifier goes, you are, of course, just like with any other piece of equipment, going to be introducing vibration into the house. So you want to use something like, they've got these hang kits, and that's how mine is installed, is with this flexible kind of bungee system that's going to just, every time the dehumidifier kicks on, it's not going to annoy people. I've been into plenty of houses where the furnace or air conditioner kicks on and the return duct goes wham! And that's clearly a sign that, like, something has not been done right. By the way, your clients think that maybe all air conditioning systems are supposed to sound like that and that houses just suck. And when they come for a free tour at my house, they're going to see, like, oh, I've been told wrong the whole time. So please do show off your work. If you're doing work like this, please, like, organize tours, because people just need to see and feel and smell what a good house actually is like. Second thing is your filter. Big proponent of maintenance plans. If you are a builder and you are building houses like the one that I've built here, you should not trust, no offense to homeowners, I do not trust myself to handle the maintenance on this house. I have a list, I have a calendar, I have things that are going to remind me, because, like, now I've got an extra filter. And by the way, that's a MERV 13 filter that is for the secondary duct there that you can see that's not connected to anything. There's a duct collar that's black just to the right of the filter. That is for using this dehumidifier as a ventilation device also, and it's called supply only ventilation. It's bringing fresh air from outside into the house, filtering it on the way in, because you got all kinds of things outside: pollen, dust, dirt, you know, you name it, mosquitoes that are going to want to come into the house. You don't want those being distributed throughout your house. So you want to filter that stuff. That's why you just don't let infiltration happen naturally. Like, air leakage is not the answer. Building houses that breathe is like, that's just what you can watch plenty of videos on my channel about why that just doesn't work anymore. So what I'm using that for, by the way, in my crawl space, is it's not connected to anything. You see that it's slightly open, and that's because I'm using it to slightly depressurize my crawl space. So it's drawing some air from the crawl space and then distributing all that air into the conditioned space above. So it pushes air from my house down into the crawl space. Kind of an interesting thing to be able to do. I like that. So ventilation is, as I said, every house needs spot ventilation, but we're also talking about the other things on this list for mechanical ventilation. If you're building to code and you're building 5 air changes per hour or less, which is almost everybody now, it's pretty hard to be sloppy enough that you're not building an airtight home with today's materials and techniques. Trust me, I do plenty of these tests, and houses are tighter than you think. Exhaust only means you run a bath fan all the time, 24 hours a day. Or with something like an air cycler system that monitors how much it was running last hour and then says, okay, well, I'm going to run the bath fan again for another 20 minutes this hour so that I can make sure that I maintain my number that was set in there. Supply only, same thing. You can have it hooked up to a control. You can just have a duct from outside with no damper on it at all, which would be a bad idea. Going into the return plenum, every time the air handler kicks on, it sucks air both from the house through the return filter and from outside. You want to make sure that the filter is after that duct, by the way, or that there is another filter after it. Those both have their limitations. Everything has limitations, clearly, and everything creates side effects. But those two, the way to tune them is always involves testing. You have to test this stuff, period. Balanced, it would be a combination of those two. You have the duct from outside into the return plenum, and you've got the bath fan running, or kitchen exhaust, or whatever. But it would be a way to give and take. I've not ever seen that done perfectly anywhere except in my house, which I have tuned anally, and I am not doing as a professional job, right? So nobody should judge normal builders by what I have done here, because I get all the time in the world and I'm going to hand this house off to my kids. I'm just saying that it's possible. And you want to pick things as a professional that are easy and kind of plug and play and proven technologies, not try to do spaceshipy stuff like what I'm doing largely in this house. And the last thing would be energy recovery. Let me just say to anybody who's like, oh, I've heard that I need to have ERVs. No, not true. Air has almost no thermal mass at all. Air is like fluff, it's nothing. So cooling air, heating up air, drying air is a breeze. There are lots of machines out there that can do that all day long, and they're very energy efficient. And quiet too, and that's important as well, by the way, with that vibration thing. You don't want these things to be annoying because people will unplug them. Energy recovery is for houses like this one, where you've got it so tuned down that you just have to have one machine that both gives and takes at the same time. And so that, I would say that that's something that if you're not doing ventilation at all right now, don't bother with talking about energy recovery ventilators. And by the way, HRV and ERV are two different kinds of the same thing. We're going to talk about that in the third webinar. So seeing and solving the problems. This is a really cool way of approaching this that I heard from Building Science Corporation very early. It was one of the first trainings that I ever took, and it stuck with me. If you have a client who has a problem, it's going to be made of these 4 Ps. It has to be all 4 of them. First of all, there are people that live in the home. If nobody lives there, nobody cares what the air quality is. You also have to have a pollutant, and you might know what that is. You might also not know what it is. I had a great, it was one of my favorite client interactions ever. I do some distance consulting now, and so I have these people. I doubt my ability to investigate things from states and states away. But in this case, I was able to tell them, this is which kind of test you want. You want to get a blower test. You want to have the air quality tested with this pump that's going to test for VOCs and mold VOCs. And all the test data came back. And on the call, we found out that they were kind of prepper minded for blizzards. And they had put 4 canisters of gasoline in their garage. And we knew from the testing that the garage was communicating air into the house. Problem solved. Amazing. So you might not know what the pollutant is. If you do testing, you'll probably find out what it is. But that's not all. You have to have a pathway through the barrier. Garages are not supposed to breathe into the house. But that's not all. You need to have the 4th P. And the 4th P is pressure. Now, in my client's case, it was the case that stack effect, warm air rises, cool air sinks. That was enough pressure to bring that air that was loaded with gasoline fumes into the house and make my client sick. If that was not there, it would go away. Therefore, if you want to fix this problem immediately, today, you have an exhaust fan on your truck. You install exhaust fan between the garage and outside, and you depressurize the garage. You suck on it harder than the house is sucking on it. Problem solved. You can also air seal the garage. You can also just take the gasoline out into the shed, or you could move out. But all you have to do is one of those things. Don't worry about trying to do multiple things. All you need to fix it with is just one. So these are the things that you just need to keep in mind as you're trying to fix homes. Number 1 thing, kitchen exhaust. People are cooking. They are creating tons of particles. They're taking tons of chemicals that are having chemical reactions with the other things they're doing in the house. You gotta have kitchen exhaust. It has to go outside. It has to. Don't ever install a recirculating unit again, ever. It also has to work properly. And there's a really easy way to find this out with a smoke pen and no other piece of equipment, or a candle that you snuff out. I'll show you this on my YouTube channel if you want to check it out. Ventilation system, gotta have it. You need to plan for people doing Titan things to their house, replacing windows, adding insulation, caulking up their window cracks. I don't know. People do lots of stuff to their houses, and it ends up being a lot tighter than you think. So just plan for ventilation. Dehumidification, again, gotta have it. It's just like the weather's changing. People are spending more and more time inside. They're doing crazy stuff. You got 10 shower heads in a shower. I don't care what kind of exhaust system you have in that bathroom. It's not going to handle it. So you got to handle for that. Filtration is the only thing that I'm going to recommend as far as air cleaning. And HEPA vacuum. And by the way, the last thing is surface washing. How do you get people to do that? I'm not sure. We're going to talk about that in the next webinar, I hope. You will notice that there is no such thing as UV light on this list. There are no electrostatic filters on this list. There are no chemical sprays on this list. Don't add to the chemistry in your clients' homes, please. Like, do your research before you start adding stuff that destroys or changes the molecular chemistry of things. So at this point, hopefully we've got some questions that you guys have been typing into your question pane. Nikki will address some of them, and I'm happy to talk about it as well. But thank you guys very much for your attention, and I hope that you you will be able to find this video on our YouTube channel. You can send it to people if you want them to watch it as well. Nikki, do we have questions?
Absolutely. All right. The first one, if my customer has high RH in their home, do they need a dehumidifier in the crawl space and on the HVAC system?
Well, I would like to hear your take on this.
Sure. Well,
but it's probably less studied than yours.
I would say typically address what is below the home first. If we've got some moisture issues going on down there, because up to 50% of the air that's below the home is going to end up inside the living space. We want to get a good handle on what's going on down there. And then after getting that taken care of, then we typically recommend monitoring the rest of the home. And if we see high relative humidity, then we're going to have to probably add one to the HVAC system.
Right. And I think that this, by the way, goes into that maintenance plan idea of like having a continual relationship with your clients, because staging your home improvements, if you think of it as like an ecosystem, if you know that everything you're about to do is going to have a side effect, do one thing at a time. Be like, we're going to install this in the crawl space. Stop. See if it makes a difference. If it fixes it, then we're done. And like, that's beautiful. If you just go whole hog and you do everything at once, like on a television makeover show, and within 24 hours, the whole house is different, you're going to have a whole suite of different weird things that now you have to go back and fix. So I agree. I think that just moving logically makes sense.
And monitoring is so important. Yes. I mean, just like with everything, if you're not measuring, you're guessing. So we gotta.
And by the way, do you guys you have a Bluetooth or a Wi-Fi data logger that Santa Fe has for your stuff, right?
We used to have that, but now that we just got partnerships with other monitoring companies to do that. But yeah, I mean, we highly recommend monitoring for even once you put one in a crawl space, you want to make sure that you are continuing to monitor that space, because you never know what can happen.
Yes.
All right, here we go. The next one. If I used the ventilating dehumidifier for ventilation, how much ventilation air can it provide?
Well, I think it depends on the size, but Nikki, do you have a?
Yep. So
you're the expert on that.
Yeah, typically with our ventilating dehumidifiers, you can get 1/3 of the total CFM from that unit for ventilation air. So that takes into account, we got to think about the static on the unit as well.
And so the collar, the one in the picture that I showed, I think that's an 8-inch collar. Can you correct me? Is that 6?
That's a 6-inch. Yep. And
and that one I think is 300 CFM or 340 or something like that.
Yeah. So what we need to do is make sure we measure the static on the unit, because that will reduce the CFM of the unit. So as soon as you add duct work, you're usually at 0.2. And then so on our website for the spec sheets for all the units, it'll give it at 0 static, 0.2, and 0.4. And so you can see what the CFM goes down to, and you can get a max of 1/3, which, your ductwork is beautiful, pulled tight. I mean, it's really nice, but we got to make sure that we understand that if we don't have really nice ductwork, that's gonna reduce it as well.
That means, by the way, for the professionals, you need to, and for any homeowners who are watching this, you need to have your dehumidifier like placed close to an exterior wall, so you can have a minimal amount of ductwork coming from outside into it. And then it should also be close to the plenum where it's going to be plugged in. If it could be a straight run with no turns at all, that would be the lowest static pressure that would be possible.
Yeah, that's perfect. Yeah. So what sort of maintenance do the dehumidifiers require?
It's pretty simple. I mean, I'm maintaining these. These obviously are pretty new, but each of them has a drain line, and that is a whole. I've got a video about just that because we have indirect traps and trap primers in this house because I've got seasonal drainage. Anyway, that not to explode your brain, but basically you gotta pay attention to the drain. Don't let it get clogged because like stuff grows, microbes are everywhere, they're gonna grow. And then also the filters, you gotta change the filters.
Yep, very important. And usually when we see, a newly encapsulated crawl space, we would change the first filter after 30 days because a lot of stuff's been stirred up down there when that happens. And then usually about every 6 months after that. And then if you're using one in a ventilating dehumidifier, because they're MERV 13 filters and really good filters, like you said, with pollen and all that other stuff, it could depend on where you live.
100%.
How often that you're going to need that.
Right, which is one thing, I don't know if this is in the plans for you guys. There are like all kinds of promises are being made on HVAC control systems and monitors, and I haven't really seen it deliver yet, but if we can have this, if you can monitor the static drop across a filter, which is not hard to do, you could have a machine that texts you when it's time to change your filter because it's stopped working, it's gotten clogged up, and you actually can measure that. So anyway, that kind of stuff is cool. By the way, let me just make one more point. I had a dehumidifier running in this house as we were building it because between the time that you dry it in and it's airtight, which was in that picture that I showed you with Landis spraying my house with a pressure washer, airtight, not electrified, no HVAC running in the house. You got to have something in there to make sure that any humidity that's migrating in through vapor diffusion or through sweating in the house or just the concrete slab, evaporating, all that stuff is taken care of. So I don't know how you would build without a dehumidifier in a house nowadays, as you build it.
Yeah, very important, especially if you're closing up during the rainy season. And construction materials have so much moisture in them.
Yes, right.
All right, one more. How do I know which size of dehumidifier I need?
This is I think that question makes me also think about how do I know how much exhaust ventilation I need in my bathrooms? How much whole house ventilation do I need? All that stuff is like totally findable. You measure your house and then you either go to the manufacturer and they'll say, like for dehumidifiers, Nikki, correct me if I'm wrong, but you guys you recommend based on square footage of the house?
Yes, and very conservatively as well.
So for example, for me, that's a 16-foot ceiling over there. If I say this room is 800 square feet, but really it's two 800 square foot rooms, and I picked one that was within that's what she's saying is that if you have high ceilings, it's okay. It's allowable within that square footage.
Yeah,
is that essentially
typically correct? Yeah, ours are based on 8 to 9 foot ceilings, our recommendations for square footages. But in our recommendations, we have found with our square footages on our recommendations on the website are very conservative. And that's because when you install a dehumidifier, you can't take into account everything that could potentially lead to more moisture than right? We have people living there. We have ventilation. We don't always know exactly what there's going to be. So it's easy to undersize a dehumidifier and not be able to manage that moisture. So we always like to, if you're on the edge of our recommendation, always go up to the next size.
And by the way, that goes for ventilation too. If you're just moving into ventilation, you want one of the fundamental things is if you have heard of ASHRAE 62.2, which is the standard that you could have an argument with me about whether it's a good standard or whatever. It's a standard. Pick a number and then be able to turn that down either by running it less often at full speed or turn it up And by the way, that either or was if you get something called an EC motor and you could actually like dial the airflow down and run it continually. That's something that I'd love to be able to do here with the ventilation in our house. Right now, I've got a time-based thing, which is like it's not working as perfectly as I want it to, but that's a topic for another webinar.
All right, I think that's all we have for today.
Awesome. Thank you, everybody, and thank you to Santa Fe and Ultra-Aire for making this possible.
Thank you, everyone. Have a great day.